Intermediate Algebra for Statistics, Powers of Polynomials, Product of Binomial Conjugates, Part 2. Lesson Objectives: Simplify the square of a binomial. Find the product of two binomial conjugates. We'll begin with an example. Example 3. For f of x equals x squared minus 5x, find the following. Number 1, f of a minus 3. Number 2, f of a plus 2 minus f of a. Solution: a minus 3 is our input, so wherever we see an x in this expression, we're going to substitute the binomial a minus 3. Our next step is following the order of operation. We have to square first, so we have to take a minus 3 squared. So if you recall, we square the first, we double the product, and we square the last. So this will be a squared minus 6a plus 9. Then we would distribute the negative 5 to the a and the negative 5 to the negative 3. Next, we combining the like terms, so we have minus 6a minus 5a becomes minus 11a, and we have a positive 9 and a positive 15, and that becomes a positive 24. So when the input is a minus 3, the output for this function is a squared minus 11a plus 24. Let's do number 2. So we want to find f of a plus 2 minus f of a. So for this first part, the a plus 2, this is our x squared minus 5x. And then for the f of a, we have our x squared minus 5x. Again, we have to square first. A plus 2 quantity squared. We square the first, double the product, and square the last. We'll get a squared plus 4a plus 4. Then we have to distribute the negative 5, and we get negative 5a minus 10. Then we have to subtract f of a, which is a squared minus 5a. So distributing the negative sign, we have minus a squared plus 5a. Next, we combine like terms. A squared and negative a cancel. We have 4a plus negative 5a plus 5a, which becomes 4a. And then we have 4 plus negative 10, which is a negative 6. So the final answer is 4a minus 6. Example 4. Write f of x equals negative 3 times the quantity x minus 4 quantity squared plus 8 in standard form. If you recall, standard form of a quadratic is ax squared plus bx plus c. We want only one term, x squared. This has an x minus 4 squared. Our first step in writing this in standard form is we have to unsquare this. Now, we can't distribute the negative here because we would be breaking the order of operation. We have to square first before we multiply. So our first step is to square x minus 4. So x minus 4 squared is x squared minus 8x plus 16. Square the first, x squared, double the product, that would be double negative 4x, which is negative 8x, and then square negative 4, and we get 16. Now we can distribute the negative 3 to the 3 terms and combine like terms, and we get negative 3x squared plus 24x minus 40. This is in standard form. We can verify our work using the graphing calculator. We type in the original problem in y1, and in y2 we type in our final answer. We can hit graph, and we can see that both graphs look exactly the same. Or you can even use the table feature. Lesson objective: product of a binomial conjugate. A conjugate simply means that if we have A plus B, the conjugate to A plus B is A minus B. The signs are different. Now when we take the product of two conjugates, we get this. And we would say in words, the product of two binomial conjugates is the difference of the square of the first term and the square of the second term. Let's see why this is. So if we have A plus B times A minus B, we will get A times A, which is A squared, A times negative B, which is negative AB, B times A, which is AB, and B times a negative B is a negative B squared. Now if we notice, what happens to the middle term is it will cancel, and we are left with A squared minus B squared. Let's do some examples. Example 5. Number 1, we want x plus 6 times x minus 6. Number 2, 3p minus 8q times 3p plus 8q. Number 3, 4m squared minus 7rt times 4m squared plus 7rt. And lastly, number 4, x plus 3 times x minus 3 times x squared plus 9. Let's begin with number 1. So if we look carefully, x plus 3 and x minus 3, these are conjugates. We square the first term, x squared, minus the square of the last term. 6 squared is 6 times 6, which is 36. So our final answer is x squared minus 36. Now, if we fold this out, we would get the same exact answer. These middle terms, positive 6x and a negative 6x, would cancel. Number 2, and here again we have two conjugates. So we square the first term, 3p, minus the last term squared, 8q. 3p squared is 3 squared p squared, which is 9p squared, minus 8 squared q squared, which is 64q squared. So our final answer is 9p squared minus 64q squared. And we are finished. Number 3, again we have conjugates again. So we take the first term, square it, minus the second term squared. That gives us 16m to the fourth minus 49 r squared t squared. And we are finished. Number 4, if we multiply these two first, and notice these are conjugates again, square the first minus square the last, and we get x squared minus 9. And then we are multiplying that by x squared plus 9. And if we look, these are now conjugates. So now we square the first term, x squared squared is x to the fourth, minus the last term squared, which is 81. So we have x to the fourth minus 81. So let's review. If we have a binomial that is squared involving sum that is equal to first term squared, double the product, square the last. If the square involves subtraction, it is essentially the same thing. Take the first term, square it, double the product, and then square the last term. And finally, if we're multiplying conjugates, square the first term minus square the last term. Thanks for watching.